So the current focus on climate change globally is to try and retain the temperature rise to within 1.5 to 3 degrees centigrade. It's really optimistic to think we can retain temperature rise to within 3 degrees centigrade. 1.5 has gone already. We have a very serious problem facing us. Now, there's been a lot written recently about the impacts of heat waves. I mean, one of the things that's happened in Australia is that we've gone through 2 or 3 quite cool summers, and people's attention span tends to be pretty low in this space. So people have started not worrying so much about extreme heat. But these are words from about 2 weeks ago in the journal Nature, and it shows what's happening in Western Europe. And there's a couple of really important points to make here, and I'll just briefly read it. Extreme heat is one of the more deadly consequences of global warming. It kills people directly, such as those working outdoors, and it overloads energy grids, disrupting electricity supplies at times when people most need air conditioning or fans to survive in overheated homes. A heat wave in Europe in 2003 is estimated to have killed more than 70,000 people. And these numbers don't get reported very often, but that's stunning and something we should be deeply concerned about. And then the second quote is perhaps even more alarming, that climate scientists have long warned that heat waves will strike more frequently and with higher temperatures as the world warms. But the future has arrived faster than researchers had feared. The modellers are now openly conceding that they've got it wrong, and that the rise in temperature, and in particular the rise in extreme heat events, is well beyond anything that anyone's predicted. And of course, there's all kinds of impacts of that. This is another piece of quite recent data published this year in Nature Climate Change, of the number of diseases they've discovered that are negatively impacted by extreme weather events. So all of these diseases get worse under those conditions. And these are all things that we have to live with into the future. This is what happens in the plant when you put it under drought. So we've got those same photos at the top. Stomatoconductance here, this is the stomates open, the plant's happy, it's got lots of water, it's losing a lot of water, but it's taking up a lot of carbon dioxide. When it has increasing drought conditions, the stomates eventually close, and they close quite rapidly. So have this quite intense period where the stomates shut up. They shut up because they don't want the plant to lose any more water, and they just want to sit there and try and ride out the drought. The trouble is the cuticle, which is the waxy coating on the leaves, also loses water, but much more slowly. If the drought keeps going on, the plant continues to lose water. It loses it slowly, but it loses it. And eventually the impact of that is you start getting more of this embolism. So embolism tends to really kick in after the stomates close if the drought keeps going. And eventually you get to the point where it starts to go into this steep curve where cavitation is happening. And the critical points here are that point there, which is where most conifers die, and this point here where most flowering plants die. So that's the way in which plants react to drought. Here's a pair of photos we took in 2018 in summer. It was very early in summer, so these plane trees had just produced their leaves, and this was them in the morning of that day. The day was just above 45 degrees, and this was the same group of leaves in the afternoon. That's leaf scorch. So those are dead leaves. The plant will shed those leaves, and there's every chance they'll produce some new leaves to replace them. So basically, if you put a plant into drought and heat stress, if it doesn't go for too long, then the plant can recover quite quickly and at fairly minimal cost. So you get back to where you were. And all plants go through that cycle. And if they can't do that, then you really, really don't want to have them growing in your environment. Then you get down into the space where you get some damage, like the leaf scorch that we've just seen. That's a slightly more serious issue. The plant can recover fully by just putting out a new flush of leaves, but it does it at greater carbon cost. It's going to hurt the tree to do that, and you don't want to do that to the tree too often, or it will start to suffer. And then, of course, you get the situation where you get physical damage to the trees, whole branches dying, the plant's really in trouble. Sometimes trees can recover from that, but they don't recover to their previous situation, at least certainly not quickly, and it costs them a lot to do so. There's a high carbon cost in that. And of course, when things get really grim, the tree dies, and the carbon cost is the carbon that the tree holds. So I just want to come back to this point about how different trees in similar environments can do quite different things. There's so many things in a tree that can vary. And you just need to look at the right-hand side of this. I'm not going to go into detail, but I just want to make the point that there are a lot of aspects of the leaves and the shoots that vary in a plant. There's lots of aspects about the stems that vary in the plant, and there's a lot of aspects in the root systems that vary. So when you're trying to select a tree to go into a particular environment, there's a lot of different things you need to be able to consider in order to work out whether or not that tree is going to be successful in the place you're planning on putting it. A really good example of how different plants can be, different species in the same environment, is this photo taken recently in New South Wales during a quite severe drought. This is a eucalypt forest with a small patch of calitris in amongst it. The eucalypts are basically all dead or dying. The calitris look like they're having a fine time. Calitris are very, very safe plants. Eucalypts are very efficient plants, but not very safe. You put them in a drought, they'll just transpire themselves to death. Some eucalypts don't know how to close their stomates. They just keep on going and hoping it'll be okay. They grow very quickly as a result, but they're not always smart choices of plants to put into places that are going to be quite stressful, especially in terms of temperature and water. If we go back to these graphs again, I think for a long time our focus in selecting species to plant in cities has been up here. What does best in these conditions? For the future, without question, we have to change that focus and say what does best down here. This is what's going to really count for the future. The only way we're going to answer those questions is with detailed physiological data, where there's just not enough work being done on the physiology of the kinds of species we're thinking about putting into our environment, and that's the direction I think the effort should go into the future.